Okay. And we're back. This is Colombia Calling, episode 463. You'll have noticed that we're going through sort of a stretch of people with academic backgrounds, and this episode is no different. It's very exciting for me to have here Natalia Pardo, who is assistant professor of the Department of Geosciences at the Universidad de los Andes. She's a geologist from the Universidad Nacional. She got her master's in volcanology at Mexico in the UNAM and her PhD from Massey University in New Zealand. So welcome on the Colombia Calling podcast.
Thank you very much for this invitation.
No, the pleasure is mine, and the pleasure is that of my listeners, because I get all geeked out by these things. We had Camila Gonzalez Rosas a few weeks ago talking about infectious tropical diseases, and now we've got the expert on volcanoes in Colombia. And I know you've just come back from Boyacá, and tomorrow you're off to Nariño. And by virtue of the fact that I love coffee, I know that it's comes volcanic earth in Nariño. Just tell us a little something. What are you going to do down in Nariño?
Yeah, well, this is going to be an exciting trip because it's the time for giving back to the local communities what we've learned all these years. So this is going to be more like a space to share, to translate what we do in a plain language that can reach the people who needs to be reached. So this is going to be a multidisciplinary trip with colleagues from design and from education who managed to translate one of my papers that we developed together with the Geological Survey of Colombia a few years ago with the geological map of the volcano. They managed to translate that into a graphic novel. So we're gonna launch the novel there, which is gonna be the first public to reach, the first space, the first dialogue, and the first show up.
And so this graphic novel explains volcanoes and where the people, and I imagine it's a very rural community, perhaps with not the highest literary rates and so on. So tell us, is it one that sort of explains everything for them? It takes your academic work and puts it into normal language.
Exactly. So it's a huge challenge because yes, it is a rural community, but also in Colombia, we don't have much of geology or earth sciences in school. So we need to start from zero, from how the earth works, how tectonic plates move, what's the position of Colombia in that puzzle. It's a jigsaw so in the planet. And then from there, we try to explain specifically the Pacific Ring of Fire, and within the Pacific Ring of Fire, then southern Colombian volcanoes, and then we focus on Dona Juana Volcano, which is the inhabited volcano here, the one where we work.
Wow. And tell us about Dona Juana. It's not dormant, it's an active volcano. Aren't all volcanoes active, really?
It depends on what do you mean by active. And we think that we reached a common language, but among volcanologists, but I think it's important to stabilize like a baseline. So given that we've only been here for a couple of millions of years, everything that has erupted in the past 10,000, it's potentially active. So it might not be erupting at the moment, but it could awake, it could start a new phase. And so we consider that if it is erupting at the moment, okay, that's normally an active volcano for everyone. But the fact that it hasn't been erupted in the last years, it doesn't mean that it's over. And so we think that if it has done an eruption during the last 10,000 years, it's completely capable of doing one again. And we actually see that the potential new eruption is going to be as the most frequent eruptions that that volcano does. So at the end, it's a matter of understanding how a volcano behaves normally without excluding extremes. So we actually also targeted the extreme events, the worst case scenarios. But Dona Juana is more like fuego in Guatemala. We call it a volcanic volcano. It listens a bit odd, but it's what it means is that it's a plugged system. So it has a conduit that connects the magma chamber with the surface of the earth, but that conduit is blocked by eruption. So there's like a plug there that needs to be removed, and that removal is a bit it's violent, but it also modulates and complicates that explosivity. So it's not like the most dangerous thing that you could have on Earth. There are far worse explosive eruptions like Vesuvius, but this one is large enough to cause local ecosystem changes, like changes in ecosystems, changes in the local river basins. Basically, as you said, these are coffee lands, so it has implications for crops. And
wonderful. So where, I've got so many questions. Where is Dona Juana exactly located?
Yes, so this is northeastern Nariño. So we are in the southernmost department of the countries, the southernmost state, and the capital of that state is Pasto. Close to Pasto, there's a famous volcano that is called Galeras. And this is northeast from there towards Cauca, which is the next state. So it's just in what we call the Macizo Colombiano, so where most of them or many of the major rivers are like burning.
Yeah, they find their source in these areas. And what are the towns around Dona Juana? I mean, because I'm just sort of trying to put it into my head, because I know Nariño, I know Cauca, and I know there's all sorts of problems as well. It's a very complex part of Colombia. But what are the towns in the immediate area?
Yeah, so Las Mesas, which is where we're going now. Las Mesas is part of Tablón de Gómez. That is like the major municipality there. So it's the upper river catchment of the Juanambu River, full of history. Yes. To the north, you might have La Cruz or Tajumbina, but then you reach like a shared territory with the neighbor volcano, which is Animas, which is poorly known. And that is like Vesuvius. That one is more dangerous.
And so why aren't you studying that one?
Because it's a bit dangerous to go.
Really? I mean, there is a likelihood of an explosive activity, or is there a likelihood of something happening?
In Animas, we have our typical Colombian problems of armed conflict. So another danger. It's not easy to get there to feel safe while you do your field work, and it's a tough mountain. So at the end, you have to prepare a huge logistic to be able to camp there and to be safe while you work. So when you don't feel safe, then you need to set up like a priority list. But in any case, Dona Juana was first, because when you do a priority list, you have to take into account the historical record as well. So what is written or what has been told, it's important, because then those memories, the social memories, what gives you an idea of these low frequency eruptions that might be lost in the geological record, but they are fixed in the memories of the inhabitants. And that is the case of Dona Juana, whereas Animas is not in the social memory. So the last one could have been ages ago compared to Dona Juana. So and Dona Juana last erupted at the end of the 19th century, the beginning of the 20th century.
Oh, really? So yeah, there's the danger of explosive activity, but of a different type. Let's put it that way. And I can understand that. And of course, we talked about that with Camila Gonzalez Rosas as well, you know, her studies in these areas. So I find this fascinating. And now I imagine this, we're looking at Nariño Cauca area. So it's a large, if not majority, indigenous population. And so the history is more oral, I guess, not written down. So this must be fascinating to you to have to sit down and listen to the elders talk about what maybe their grandparents and their great grandparents remember. That's an enriching opportunity.
Exactly. This is exactly what we do. So we hunt the record in the stratigraphy. So what the volcano has left in the landscape, and especially within the river catchments, that's where we look the mosaic of past explosive eruptions. But there are many that are lost by the wind, by the rainfall, by even earthquakes that removed all this material as mass movements. So we lose a lot of the record, and we try to fill those gaps with this oral history. It's not always easy. Cauca is very indigenous, but this area is campesina. Okay. So, and it's like a place where migrations related to economical reasons, to war, to the complex construction of the country, results in also a fragmentary oral history. So it's not easy to recover, but there are elders, and there are elders remembering their grandparents and grandparents' history. So fortunately, there was a geographer of Quindío, who another region, who got fascinated about recovering the oral history of disasters in Colombia. And so there is a book that we have, and that allows us to read some of the testimonies of people who are not longer with us, but they fragments of those oral histories. But it's really a challenge, no? It was it's one of those forgotten places related to Bogotá. So Bogotá is extremely centralized, and how the country has built its own history. It's really tortuous, and it's really influenced or biased by whoever writes the history. So what we know, it's really complicated, and that is why it's so important to work with other disciplines as well. So with historians, people in
but that's it. I mean, that's so much of the story of Colombia being Bogota centric, and and these things, and a region such as, you know, Nariño, northeastern Nariño, southern Cauca is really going to be the last on the list. You know, I mean, not talking about the Amazonian regions and so on with so little population, but this is an area that has had that migration, which is not a romantic migration. It's not like go west, young man, out of the United States. This is almost forced migration, as you say, for economic reasons. I wanted to ask, though, something else in technical. So you said you go to the rivers. So when you're at the rivers to study the rock strata, I guess that's where you can see the layers of what has happened. It's like I don't know, almost like a diary of events. How far can you go back in these events? How far back can you see?
We were able to see, we think that we see as almost 2 million years.
Wow.
But this is an age that was recovered from a technique that is called argon radiometric dating, and it's possible within tiny crystals that are full of potassium, and so potassium is radioactive and it decays, and we can manage to recover it, how much has it decayed into the daughter. the isotopic daughter, we call it.
Okay.
But so as a challenge, because at the end is an age of crystallization, not necessarily of eruption. So those tiny crystals could have crystallized within the magma chamber before erupting. So we try to get close to the moment of the eruption, but we're not fully certain. However, like the mapping gives you an idea of that age as well. And then we are certain is where we can use radiocarbon dating. So radiocarbon, it's another method. It requires organic matter to be preserved and to host the history of when was it burned, basically. Transformed into charcoal and buried. And then it has a limit. We cannot use the technique beyond 50,000 years. Actually, in southern Colombia, we haven't been able to reach more than 45,000 years. So when we use that technique in Dona Juana, we've reached close to 6,000, pretty confident.
Okay.
And beyond that, we have these Pleistocene stories of the volcano that are challenging to measure. But then Argon has been our best chance, although there is a friend, a colleague in Arizona who's helping us with another technique that is called uranium lead, and it's used in another mineral that is called zircon, and that guy might have another piece of the story. But so we're mostly talking about volcanoes. Most of the active volcanoes in Colombia reached that 2 million years, and then they've been growing and collapsing. So they destroy themselves and regrow, and then get destroyed again and regrow. And so the youngest volcano within that volcano family, it's what we call young Dona Juana, and so we know that it has been erupting since close to 6,000 years.
I mean, 6,000 years is a matter of seconds in your work, really. I mean, that's it. And all of this stuff, when you talk about the uranium dating and the carbon dating, and well, you said that your colleague at the University of Arizona is helping, but is all of this, these techniques accessible here in Colombia? I mean, do you have these kind of, is there the capacity to do these studies, or do you always have to bring in colleagues from the United States or elsewhere?
So the capacity is installed for and in the Geological Survey. So as far as you belong to the Geological Survey, you can access the equipment, and they have amazing technicians and a huge lab that is called that's within the direction of Asuntos Nucleares, we call it. So nuclear businesses. But so they can do uranium lead, and they are now, if I'm not wrong, they are calibrating radiocarbon as well. But for whoever is not involved within the Geological Survey, because they have a huge demand in size, so they're not able to open the lab for universities, for instance. So in that case, we just use our colleagues and friends in other universities. So in my case, radiocarbon is basically done in Switzerland, and then with argon was done in Oregon, for instance. So we managed to build up this network of collaboration, and so that also because we try to look for labs who have been decades working, so we have confidence of a huge experience.
Well, I mean, academic collaboration is so important anyway, because it just opens that the knowledge base to. So I was reading all about your background, excuse me, and one of your key investigations is not just bridging the knowledge, geoscientific knowledge so that people in the regions can understand, which I believe very strongly about. But it's also about the physicochemical processes that trigger eruptions. Now, let's put that into in regular language. This is, the causes for eruptions, really, I guess, is what it means. And so we'll be talking about plate tectonics. We'll be talking about earth shifting. What are we talking about here?
Okay, so I'm fascinated about how and why eruptions are explosive. So there are ways how molten rock, or what we call magma, can reach the surface. Probably you are more familiar with Hawaiian style eruptions, which are fascinating for filming pictures, and they're really beautiful. Those are tranquil. Those are what we call effusive. So you can actually get close to them and video record them and take them pictures and things like that. But then there are ways how that molten rock or magma, it's able to host gas inside. And when you have gas, there are many paths that gas can reach the surface as well. So it's strongly related to the viscosity of the magma. So if you have a very thick viscous magma, it's really hard for that gas to escape. And then that starts to reach up the conditions to build up pressure. So it's actually more or less what happens with a Coke when you shake it and then you suddenly open the bottle. So you have that gas inside. You can't see it when the Coke is black, but as far as you shake it and open the top, then that gas releases explosively. So it's like a competition of the amount of gas that you have as a start, then how that gas is able to make bubbles, and then how those bubbles connect and grow and build up pressure inside. So it's complex situation because it's like a physics of gases and bubbles. But so that is really nice to explore when you see the texture of pumice rocks, for instance. So pumice or scoria are textures of volcanic rocks hosting the history of those bubbles. And so we try to use techniques such as microtomography, which is another version of what medical doctors use to look for tumors, for instance. But then you use higher energies, and then you can see rocks inside. And so those textures are the memories of those degassing paths. What we call is like degassing paths. Also, the crystallinity of the rocks tells you a lot about that way of getting out, basically. So that is one of the questions, like how those bubbles grow and interact and finally explode. The viscosity has also a chemical reason to be more or less than another magma. But also, if the magma interacts with external water, then that creates an exciting phenomena that has been studied, for instance, in nuclear explosions and experiments, that we call molten fuel coolant interaction. So it's something that happens when you have a liquid that is super hot compared to another one that is relatively very cold. So in this case, you have magma, I think higher at temperatures higher than 600 Celsius degrees. And then you have an aquifer or a crater lake or snow. But usually the problem, or not the problem, but the explosion occurs when you have an aquifer, which is the source of the water that we drink comes from aquifers, right? So it's ambient temperature, and then you interact, the magma interacts with that water, and what explodes is the water, not the magma itself. It's just like the explosion of the magma is a consequence of the explosion of the aquifer. And that creates really explosive eruptions as well that we've seen in Tonga or in White Island in New Zealand as well, or in Poás in Costa Rica. So they are shorter and smaller compared to the other ones, but they often happen in touristic volcanoes. So if you're in the crater, then at the end, it's also dangerous. So, and then in that case, we don't study the texture of pumice, but we study the morphology of the ashes, of the smallest particles. And then we use, for instance, electron microscopes like ECMs, or electron microprobes, like other equipments that we use to reach those tiny little particles. So at the end is an adventure behind shapes and textures, and shapes and textures provide you the clues about why the magma, which is fluid, suddenly is fragile.
So there was a Netflix documentary, wasn't there, about the New Zealand island? Was that the White Volcano? What was it? The one?
Yeah. White Island.
So were you there doing your PhD when that happened?
I was southern, but I was in the island, and my PhD supervisor deeply involved into that research as well.
I have a question then, because you mentioned at the beginning, so you're talking about the water, and so I'm visualizing Crater Lake in Oregon right now when you talk about the water, but I'm visualizing also when you talked about the plug, obviously blocking these volcanoes. So I guess Dona Juana has the plug. I think of it like a cork in a wine bottle type thing. Now, is that like what happened in Almero, which then the pressure grew up and blew the side out of the volcano? Is this what could happen at Dona Juana as well, this kind of thing?
It's a bit different. Okay. So yeah, a bit different. So Almero was a partially blocked system probably, but the eruption was really tiny. Really? And the problem there was, well, tiny compared with the two other eruptions.
It was the river, surely, in the...
The problem at the end was that eruption was able to melt the glacier that back then thick enough to produce a complex mixture of mud, really thick mud that was able to canalize along the river systems. And the problem there was the location of Almero at the where the river discharges all that amount of mud. But the problem there then was that combination of a glacier that was molten by an eruption, and then that mixture is like a concrete, like a wet concrete that moves really fast and discharges and buries everything really quick. Dona Juana is not glacier; it has no glacier on top, which is not a reason to exclude the production of those mixtures. It actually produces the mixtures mostly because you at the end need external water and what we call pyroclasts available. So sediments available. So as soon as you have an eruption, an explosive eruption, you produce those fragments, those sediments, and if you block a river, then you have like a dam. And that dam can just be removed and release a lot of that mud mixture that we call Lahar. So that's another mechanism that is actually quite possible and probable in most of these volcanoes and Andean volcanoes, because we have a huge topography and a river catchment that connects the volcano to a lower base level. But in Dona Juana is more like what you were saying about the cork. And this plug is actually blocking the conduit, and the release, how you release that plug is the real issue. So at the end, what we know is that it can release particles to the atmosphere. The ashes can reach the Pacific coast. That is manageable. So it's a matter of leading with ashes, something that people living on active volcanoes can do. But the problem is if that column of particles and gas collapse. And in Dona Juana, they can actually collapse. So more similar to what Fuego in Guatemala did in 2019. So those phenomena are really dangerous, and they are called pyroclastic current, really fast and hot.
When you talk about this, is this the same that happened with that Icelandic volcano that blocked all the flights in Europe some years ago? What was it called? It was really. Say that again.
If I can say it right, it's something like Eyjafjallajökull.
Yeah, was that a pyroclastic event?
Yeah, that was that. Yeah. So what we can expect in the atmosphere is something similar. But what we can expect in the rivers, in the river valleys close to the volcanoes, it's even worse, because that really column collapse causes this avalanche of gases that are really hot, and they can fill river valleys, but they can also jump, burn, bury. They can ingest vegetation, and that gets even worse, because this provides carbon dioxide into the system. So it's really complicated and dangerous. It's like a small version of Pompeii. Like, it's not the version or its version, but it's like a small version.
So, people out there don't know. My father was a geologist and a geophysicist, so my knowledge, but my interest goes a little bit deeper, because I grew up with the chatter about rocks and formations and so on. But I think it's timely for us to talk about, as we wind this down, is predictions of volcanic activity. Now, I was reading a very recent article about earthquakes, obviously in the aftermath of the absolute tragedy in Turkey and Syria, the 7.8 on the Richter scale earthquake. But in Nature magazine, that's obviously took place in February, Nature magazine says earthquake prediction is the stuff of science fiction. Is it the same for volcanic explosion predictions?
Volcanoes are a bit more generous than earthquakes in that. So they can give you signals of changes that can be monitored if you have the proper monitoring and surveillance system. Okay. So that a proper network of volcanological observatories, that means having seismic stations, but also that combines with monitoring how the volcano inflates or deflates. So something that you can measure with satellites and GPS systems. Also, a geochemical monitoring network, so you can measure temperatures, how the pH or the acidity of the water changes before magma reaches the eruptible magma chambers. So the most important is the seismological network, and is the least what you need to try to anticipate if something is reaching the surface. Now, the problem is, once the magma chamber is replenished, how much time do you have to move? And this is something that is really complicated. And so at the end, with a proper monitoring system, you might have a couple of weeks, a month in advance to think and take the good decisions that minimize losses and especially casualties. Yeah. However, there are eruptions that are really, really, really challenging and really difficult to predict. And those are the ones involving these aquifers, the magma water interaction that I was talking about, or even there are eruptions called blue sky eruptions. They call it like that in New Zealand, but they might be phreatic in the scientific terminology. What it means is that the hydrothermal system becomes unstable, and then that is the one that erupts. So it's not really molten magma reaching the surface, but it might it might cause perturbations in the vapor and water system surrounding the volcano, and then that system is the one that becomes unstable and erupts. Those are really tricky to anticipate, and one of them was actually White Island, for instance. And there are some, the little ones actually are the difficult ones to anticipate. And the problem of that is that you become confident to visit the craters, and then that increases the potential hazard, at least for hikers or people who are really close to craters.
I think I went up. It was Volcan Agua in Guatemala, and it was pretty hot up there. I mean, we could, and sulfurous. Also, the most visited one, I guess, in Central America, not Poas, I've been there, but maybe Masaya in Nicaragua, where everyone's sort of snowboarding down it. I mean, could you imagine? You know, it's sandboarding, but Mount St. Helens, I thought about as well. They did spot the bulge, didn't they? The bulge taking place.
Yeah, so Mount St. Helens is really an icon in the volcanological literature.
Yeah. So, okay, and now that, I mean, it's very much in my mind because only a few weeks ago we had the 5.9 earthquake that shook everything through Colombia and Bogotá and woke my wife up. I would have slept through it, but she woke me up too. But does that give you information that something might be happening in Colombia? Do we think that this is, I think of my question, and I know it's a question that you can't answer because you're an academic and it's science, but can we expect a volcanic eruption before long in our lifetime in Colombia, a big one, a bad one?
Yeah, there's always a chance. As we live with earthquakes and we live with volcanoes, and something that is a consequence of being in this part of the world where we have two oceanic plates interact with a continental plate. So the northwestern corner of South America is extremely active in terms of tectonics. So yeah, actually we expect large earthquakes, and also we can expect large volcanic eruptions. It's just that the Earth doesn't behave like an alarm clock, and the frequencies are not within the human scale. No, it's not that you can say, okay, Machin volcano, it's gonna do the next one in, I don't know, 50 years, 20 years. No, we're not able to see that. What we can do is to monitor, do the surveillance analysis, which is done 24 hours during the whole year. The volcano observatories are monitoring the signals. And then when changes are recorded, then you increase the alert level. So it's like traffic light that you use to move from a green situation when we are just in our lives living, and we know that we live with volcanoes, but we enjoy more like the benefit of being there and go to one towards yellow level, and then to orange level, and from orange to red. So then those are ranges that we need to become aware of, just to make better decisions from an individual level towards a family level, towards a community level. It's not that you can blame someone for your own decisions, but we need to be aware that we live in a really active country, and then in any moment a magma chamber can
so which volcano here is in Colombia is red?
None.
Okay,
we
good.
have we are in yellow with Nevada Rosas. Anyway, lava dome. It's partially plugged. Then one of those plugs is coming out, and this is why we had ash emission a few days ago as well. So part of it releases. Sometimes it breaks at the limit of the magma and the viscous magma and its walls. Then you have some places where gas can become over pressurized, and then you can have this little ash emission. So Nevada Ruiz, it's been like that since 2015. It started in 2011 again. But then you talk to someone in Manizales and they are very used to that. They are close to the volcano. They see it every day. And then you have the others that are presenting changes, so they deserve attention. And that hospitals need to have protocols, that volunteers and civil defense need to have committees that are constantly training on what to do in case of. So you have a community that needs to have a plan. That's the current stage.
Okay.
If it's orange, then another.
But there's no orange ones. We're in yellow. Okay. There's someone reversing a truck near your house, which we all had to listen to, but that's okay. That's what it is. And so, okay, Novela del Ruiz is our one. I think it's absolutely. I just think it's fascinating. I really do, and that there is a whole protocol in process. If something moves up to yellow or to orange, you're telling the hospitals, you're telling the volunteers. I think this is great. Does that mean that Colombia is more or less ready just in case something happens? Or because there's a book that came out and I've forgotten what it's called and I've forgotten the author, but I saw an interview, and it was this last week, about the readiness for like a mass disaster in South America. And I mean, I don't need to read it to be able to say I'm fairly certain that we're not ready.
No, we're not ready. But because so the framework of disasters are a bit complicated, and they do not only depend on nature. So the part that we can measure, that we can quantify, that we can kind of understand is the hazard component. So what nature able to do? What is the most frequent scenario? What is the worst scenario? That is something that we are able to read from this geological past of the volcano, and also from the current state of the volcano with the geophysical and geochemical tools at the observatories. So we can try to estimate hazard. So what is the probability of occurrence of something that might be dangerous for? And then you have the rest of the framework, which depends on the vulnerability of the systems that are exposed to those hazards. So for instance, you have ecosystems vulnerabilities or environmental vulnerabilities. You have infrastructure vulnerabilities, which are the easiest to quantify. That's something that civil engineers do quite a lot, quite often, to design the structures. But you also have one that is really challenging, and is the social and organizational vulnerabilities. And those increase where you have a huge gap in the socioeconomical structure of any society, and also the ability to respond and the capacity building exercises, the ability to take decisions, not just to think them, to take them. It's something that is intrinsically related to your socioeconomical level, but also to the connectivity within your community. And in our situation, that is really low. So for instance, and it's difficult to quantify, and it's difficult to measure, and it's difficult to monitor now how the community might be able to cope with what is going on, and then the ability to recover from what happened. And so besides the socioeconomical situation, the armed conflict really complicates things. And so it is really, well, so when we are measured in these risk levels in the world, so UNESCO has an informed, it's called informed disaster risk reduction, something like that. And it's like a way to put as numbers. And we are always with worrying numbers, but what makes us really bad at recovering or at coping with is this huge fragmentation within society. And so the countries with armed conflict are really really like the worst place you can have in terms of disasters.
Yeah, I think that's an incredible point, that on the social vulnerability, the armed conflict, and of course the people in the lowest socioeconomic bracket, those who have struggled, who have been displaced, who have found their little plot of land in order to survive, that's basically it, are the most at risk. Who wants to give up their land? They've already probably abandoned land before, or they've lost it in some other way.
They won't go, because then you always have that difficult decision of, and then what will I do?
Yeah.
And sometimes people are more afraid of after the disaster, surviving after, than just assuming the risk. And so that is something that is also really important, that many people are from wealthier countries, the general sentence that you listen to is like, oh, but why they do live there if they know something is going to happen? But it's something that is not that easy, and it's not that easy to just move out. It's not that easy to imagine yourself and your family to start over in a new place without the minimum conditions to start. And so those minimum conditions are a challenge for the state. And that is something that we've got even with mass movements like McColl in 2000.
I knew you were going to say it, and I was going to say it, McColl, and I reported on it a lot, for various outlets. And the questions always were, why do people live there? And like, they've got nowhere else. It's the people who live.
It's not. It's also like as you were saying, when these campesinos and indigenous communities have a strong bond to their land. Their land is the way and the reason to be alive. And as in many regions and in many cultures, and even not only in Colombia, it's like your blood is there, so your family lineage is there. So it's not easy also to choose another place, because in countries like this one, you will face nature every. It's not, if it's not the earthquake, it's mass movements. If not this, then you have floods. We have ENSO, so El Niño, La Niña, all this climate and extreme weather conditions are really tough in the tropics. If not, you have tsunamis. If not, so it's like it's not a matter of running out, but a matter of increase this capacity building up, living with nature.
This is where you need your social scientists to come in and do these studies. I'm a social scientist, employ me. That said, Natalia, thank you so much. This has been fascinating. I know my listeners will agree. It really has been very special to hear from you, and you speak with such authority, as I would hope so as well, and about this topic, and I just think, we live in, I don't even know how many volcanoes there are in Colombia, but we live them. They're everywhere, really. So let me take this moment to say thank you so much for your time, for sharing this knowledge so unselfishly. We've been talking to Natalia Pardo. She's got all sorts of academic articles out there that are fascinating to read if the desire so takes you. She's the assistant professor of the Department of Geosciences at the Universidad de los Andes in downtown Bogotá. He got her undergraduate at the Universidad Nacional in geology. She got her master's in volcanology at the Universidad Nacional de Mexico, UNAM, and she got her PhD from Massey University in New Zealand. So we have been talking to a true expert. Natalia, thank you so much.
Thank you. Thank you.
And good luck in your next study down in Dona Juana again. And be careful, please.
Thank you.
All right. We've been talking to Natalia Pardo. This has been episode 463 of the Colombia Calling podcast. I know you've enjoyed it. We'll go over now to some of our patrons who support us, but of course, if you fancy throwing a few dollars less of a cost of a Starbucks per week, you can support us on patreon.com/Colombia Calling. So thank you again for listening, and be sure to tune in again next week.